Okay, well, what would happen, I know you're asking, if we would have a negative in front of that value? Well, in this case, what that's going to do is that's going to cause a vertical reflection. So let's check this out with the function y equals negative 3 times sine of x. One of the reasons that we needed the absolute value symbol for our amplitude was to account for that difference. What happens if we have a negative? Well, our amplitude in this case is going to be the absolute value of negative 3, so we will still say that the amplitude is the number 3. The amplitude, remember, is a magnitude. It's the size of the distance that we take from the center axis to its maximum or minimum point. All right. The only thing that's different here for our y values, if we're going to do these comparison graphs, is that we're going to multiply each of our y values from our reference times negative 3 to get our new values. So for our sine function at x equals 0, y would equal, oops, that's the wrong one, right? Let's get the right values here. Let's get the right reference values. Our reference values here, my bad, here would be 0, 1, 0, negative 1, and 0. So we're going to multiply each of those in turn by negative 3. So we're going to get 0 times negative 3. Well, that's still 0. 1 times negative 3 is negative 3. 0. Negative 3 times negative 1 is positive 3 this time. 0 times 3, that's still 0. So let's graph at least one full cycle right here. Let's see if we can fit in more if we can. I'm going to do a cycle here from 0 on my y-axis right here and along my x-axis. We're going to plot our values here. So we're going to go from negative to positive 3 along our y-axis. Here's positive 3. Here's negative 3. Pi over 2. Pi. 3 pi over 2, and I'm always trying to place these evenly, right? They don't vary in size, right? So if you're not good at graphing, you can get good at it by just practicing putting everything at these nice evenly spaced intervals. Right? Here would be negative pi over 2 for reference sake. Okay. So what are we saying here in our graph? We're using these points, so 0, 0 is still a reference point for us, but at pi over 2, we go to negative 3 this time. At pi, we go to 0. At 3 pi over 2, we go to positive 3 this time, and so in one basic cycle, our graph looks like the sine function except flipped upside down. Okay. That's one cycle for us. If we continued on following this pattern as we went, we would see something that looked rather like this. Our graph would, of course, continue on in what we call a sinusoidal curve fashion like this. So passing through the negative 3 value, the x-axis, and back up to its maximum, and so on. You see that our maximum right here is going along with our amplitude, so our amplitude is 3. The period has not changed. We have one basic period going from 0 to 2 pi, so that's what we say is our period right here. Our domain, still all real numbers. We haven't changed anything about that domain. And the range, we go from our minimum y value at negative 3 to our maximum y value at positive 3. So that range is dependent on that amplitude, which is why we want to get it all the time. Okay, so more graphs to come.